Hello and welcome to topic 6.3. It's the last topic of the semester, and we're kind of going to condense it down. I'm not going to do all these examples, so that's good for you. Let's start with the triangle inequality theorem. Inequality are things like this: less than and greater than. So inequalities, some angles are less than other angles, some sides are less than other sides. Here's the first theorem. The sum of the lengths of any two sides must be greater than the length of the third side. So what that means, if three sides are going to form a triangle, alright, then the relationship has to be this. A and B, when I add them together, if I add A and B together, it has to be greater than C. Okay? So A plus B has to be greater than C. B plus C has to be greater than A. These two pieces added together have to be bigger than B. And C plus A has to be bigger than B. These two have to be bigger than B. Yeah, got them covered. Alright, so basically any two sides have to add up to be bigger than the third side. So here's an example. Can you make a triangle with a side length of 3, 4, and 6? Is it possible? And basically you find the two smallest ones have to add up to be bigger than the largest one. So is 3 plus 4 greater than 6? I think so. 7 is greater than 6, so that one checks out. Alright, so that means you can make a triangle with a length of 6, a length of 3, and a length of 4. It is possible to make a triangle with those lengths. Is it possible to make a triangle with lengths 6, 9, and 15? You pick the two smallest sides. Is 6 plus 9 greater than 15? Is 15 greater than 15? No. Alright, so what's happening here is you've got a length of 15, you've got a length of 6, you've got a length of 9, and there's not enough length for them to make a triangle, because 6 plus 9 add up to 15. You can make a segment with 6 and 9, and that would add up to 15, but you can't make a triangle. What about 8, 8, and 8? Alright, well, is 8 plus 8 greater than 8? Is 16 greater than 8? Yeah. You can make a triangle. In fact, that's just called an equilateral triangle, 8, 8, 8. What about 4, 8, and 16? Is 4 plus 8 greater than 16? Is 12 greater than 16? No. 12 is not greater. Again, what you're going to have something like this. You're going to have a length of 16. You're going to have a length of 4. You're going to have a length of 8. And they just won't be able to reach each other, because 16 is too far. 4 and 8 won't be able to reach each other. They won't make a triangle. Okay. So next question. Find the range for the measure. So let's say I give you 1 and 6. I say you've got a length of 6. You've got a length of 1. What could this length be so that it makes a triangle and is not short of making a triangle? And so here's the deal. There's a smallest possible length for this, and there's a largest possible length for this. Here's how you find it. What is 1 plus 6? 7. That's the largest one. So you can have 1, 6, and 7. You can't have 1, 6, and 7, but you can have anything greater. Like you could have 7's too big. You could have like 6.5. 6.5 would work. Is 1 and 6 bigger than 6.5? Yes, it is. What's the smallest possible value for this side? These do 6 minus 1. Okay, so if you're under 5, then this is too short, and if you're above 7, then this is too long. Alright, let's just do this one real quickly. It's just a process here. The largest possible would be 12 plus 18. The smallest possible is 12 minus 18. So as long as you are between 6 and 30, for example, can you make a triangle with 12, 15, and 18? Is 12 plus 15 bigger than 18? Yeah. Can you make a triangle with 8, 12, and 18? Is 8 and 12 bigger than 18? Yeah. What if I pick a number that's lower than 6? Can I make a triangle with 5, 12, and 18? What's 5 plus 12? 17. 17 is not bigger than 18. That doesn't work. What if I pick a number that's bigger than 30? Let's do 12, 18, and 40. Will that work? Does 12 and 18 add up to be bigger than 40? No, so that one doesn't work. Alright. Next question. What are the possible lengths of the legs of an isosceles triangle if the base is 10 units long? If you've got an isosceles triangle, what are the possible lengths of that? Let's think about, let's call it x. Well, it's easy to think about what's the smallest it could possibly be. What if I split 10 right in half? 5 and 5. So I know it has to be bigger than 5 because 5 and 5 make a line, not a triangle. So as long as this could be like 6 and 6, and that would have room to make a triangle. And then anything, I could make these as big as I want them to be. So it's actually infinity. So basically anything bigger than 5. X has to be bigger than 5 for this type of isosceles triangle. Example 3, we're going to skip. Brings us to our next theorem, the triangle sides and angles theorem. It says the largest angle of a triangle will be opposite of the largest side. Largest angle opposite of the largest side. And the smallest angle will be opposite the smallest side. So what is the smallest angle inside for each? So in this picture, here's the smallest side of 13. So that makes this the smallest angle. That's it. It's just the opposite of it. Opposites are the same. In this particular problem, you might be tempted to say 52 is smaller than 82, so that makes this the shortest side. But let's take a look if we're good detectives. Start with 180 in your calculator and subtract 52 and subtract 82, you get 46. So this angle ends up being 46 using 180 degrees. So this is the smallest angle, which makes this the smallest side. So GF is the smallest side. Over here, get some x's involved. So if this is x, this is less than x. This is 1 minus, or x minus 1, and this is bigger than x. So this is the largest side. This would be the medium side. This would be the small side, which makes this the small angle. So those are your winners. This is the shortest side. This is the shortest angle. Over here, a little bit more tricky. I know that this angle is bigger than this angle because this is k plus 2. However, what I don't know is what is k. So what I can do is I can start with 180 And let's start with, forget that. Start with 60, add it to k, and add it to k plus 2. And when you add up 3 angles in a triangle, it will always add up to 180 degrees. So now we got 2k, and then take over the 2 and the 60. So 180 minus 2 minus 60 be 118. And then divide 118 by 2. You get 59. So k is equal to 59, which makes this a 59 degree angle and makes this a 61 degree angle. And now we can make our conclusion: smallest angle, smallest side. Smallest angle, smallest side. Alright, that is the second theorem. Lastly, the last theorem, like I said, these notes are a little condensed. We're not going to get into the intricacies of these, is the Hinge theorem and converse, which means it works forwards and backwards. So here's the deal. If you've got that AB is the same as DE, and you've got that BC is the same as EF, then what we did here is we kind of made what we call a hinge. It's like this. Here's our hinge right there. You can think of it like a hinge of a door. Think of this as the door jamb, and think of this as the door itself. Now, if you open this hinge wide, then across from that will be wider. And if you make this hinge smaller, then across from that will be smaller. Alright, so basically here's the deal. If you've got the hinge set up where you've got a side congruent and you've got another side congruent, you can examine how large this side is by comparing the angles. Alright, so let's do some examples and hopefully it'll work out here. So here's the deal. Describe the relationship between this length and this length. Is this length equal to this length? Is this length bigger than this length? Is this length smaller than this length? That's the question we're asking. So here's the deal. We've got one side congruent to this side. We've got this side is shared. So what that does is it sets up a hinge. Now think of it as a door. This door is open 55 degrees. This door is open 51 degrees. So this door is not open as wide as this door. So that makes this across from it smaller than this. So this length is smaller because 51 is smaller than 55, and this length is larger because 55 is bigger than 51. And so WX is less than XY. That's how we'd say it. We'd use less than as our answer there. It also works with the sides. So let's see here. We've got one side. We've got this side is shared. So that's setting up a hinge right there and right there. Alright. It appears that this opening is not as wide as this opening. So because 3 is not as wide as 3.6, this angle is not as wide as this angle. Or this angle is less than this angle because 3 is less than 3.6. So angle FCD is less than, we could put a less than. FCD is less than BFC. Alright, this will be the last problem, and this one is more obvious by the picture, but let's run through it. 8 is congruent to 8. This side here is shared with this side here, which sets up the hinge. How does this compare to this? So obviously 11 is open wider than 6. So therefore this angle will be bigger than this angle. So SRT, angle SRT, is less than angle VRT. So we could use less than again for that one. And it's less than. So today we got 3 theorems. The triangle inequality theorem, the triangle sides and angles theorem, and lastly the hinge theorem. Alright, go to the next video and we'll do some homework together.